In this video, we will look at the steps for calculating covariance and correlation. Now, in the notes, don't talk a lot about, or I don't get real deep into correlation, but I just want you to be able to calculate covariance and then use covariance to calculate correlation along with using standard deviation. So for correlation, you need both covariance and standard deviations. And just have a very basic understanding of what correlation is doing. It's giving us a measure of a linear relationship between two variables, in this case x and y. In this particular first example we'll look at would be earnings per share and research and development and expenditures. And we'll assume that research and development expenditures are in millions of dollars, earnings per share is dollar. And do they tend to vary in a way that we can say as one increases the other tends to increase, or as one increases the other tends to decrease, or is there just doesn't seem to be any linear relationship? So that's what correlation, and to some and basically covariance as well, but covariance basically needs to be standardized or normalized, and we use the standard deviations to do that, which then leads us to correlation. So let's go through the steps. Now I've skipped a lot of the steps here because you should already know how to calculate a variance and standard deviation. So you can see I have, these are the original data right here, these 9 observations. I have 9 values of earnings per share and their corresponding research and development expenditures for 9 different companies. I summed each of the values up, there's 9 observations, and then I get a mean for earnings per share and a mean for research and development. So $14.67 million, earnings per share of $1.37. So to calculate the variance and standard deviation, you know that then you would take this value minus its mean and then square that deviation and then sum up all those squared deviations. This is a sample, so we're going to divide by 8, okay, rather than 9, so n minus 1. I talked about that. Basically n minus 1 is called, we'll start using that later on, not right away, but later on you'll start hearing the term degrees of freedom. And basically, degrees of freedom says if this is a sample and I have to use the sample mean to calculate these deviations. So this is y minus y bar rather than a y minus mu. Then basically only 8 of the 9 values are free to move. So if I know the mean, the x bar, and I know 8 of these values, the other value isn't free to move. I know what it will be. So I've got n minus 1 degrees of freedom. So I do that for both y and x, and so then I get my standard deviations here. And now this is what's new. This is dealing with the covariance, and we would take each value minus its mean. Let me freeze that. For y, basically we want the cross product of the deviations. So then do that for x. So 20 minus its mean of 14.67. Okay, now sometimes it'll be negative, and that's fine. Covariance is fine to be negative. If you ever get a negative variance, then you know something's wrong. But covariance, it's fine to be negative, and those cross products add up to 11.067. So now the covariance is just simply, much like calculating a variance, just simply take the sum, divide by n minus 1 because we have a sample. If we didn't have a sample, we'd go ahead and divide by n, but we have a sample. So 1.383. Okay, so let's start over again here for correlation. What we need for correlation here is the covariance Okay, because the 1.383 is telling us that, yeah, they seem to be moving in the same direction because of the positive value, but we really, that could be 1.383, it could be 1,383,000, and it doesn't really tell us the actual relative strength between the two variables. So what we do then is we take that value and we divide by the standard deviations. So SY times SX, and now we have something that we can look at and have some idea of the strength of the linear relationship. So it's positive, obviously, and 0.73. Well, if you recall, correlation can range from -1 to +1. If you get anything outside of that range, something's wrong. And so 0.7337, it's indicating some positive relationship there. But until we get into tests of significance for this particular parameter, correlation, then we really don't know that it's significantly different from 0. But just eyeballing it, anything above 0.7 is showing, has the potential of a positive relationship, and 0.8, 0.9 we might say a strong relationship. So just be able to have a very basic understanding and definition for correlation, and that's all we really need right now. You may run into correlation in finance or accounting. Correlation can be a risk measure, just like coefficient of variation. But again, what I want you to see is the use of standard deviation and how important standard deviation can be in giving us helpful information. So let's also do this for another data set, but maybe it'll come out a little differently here. Let's look at miles per gallon rating and weight of a vehicle. So you might guess, okay, what should be the relationship there if there's a linear relationship? Should it be positive? Should it be negative? Well, I think it seems like it would make sense that it would be, you would tend to think it would be a negative relationship. The greater the weight, the less likely your miles per gallon are going to be very high. So I've got these worked out already. So again, let's just work on the covariance. And for this one, I'm just going to take this cell times this cell. So it's exactly the same as what I did for the other problem, but I'm just skipping a step since I already have that done. And you can see all the negative values, and sure enough, then it sums up to minus 35,555. Okay, so a large number, a large negative number, but again, we just when we divide that by degrees of freedom, we really don't know much about what it means. A -7,111. So we really need to standardize that, and our correlation will do that. So take the covariance divided by the product of the, I don't know what happened there, let's get rid of that, product of the two standard deviations. And now you have a negative 0.965. So we could say that we have a strong negative correlation between miles per gallon and weight. Okay. Now, just one last thing. You can see that there are certain commands that you can use in Excel. Covariance.s, covariance.p. S is dealing with sample. P assumes you have a population. We didn't do any population problem. Any covariance and correlation that I have you do will be a sample. So Now you'll notice that correlation, it doesn't have an S or a P, because basically what's going to happen is for population, you would divide by n. Okay, and so the n's are just going to cancel out, and as well as the n minus 1s are going to cancel out. So it doesn't really matter whether you're calculating a variance, sample variance, or a population variance. That's going to be the same. But the covariance would differ, because dividing this number by 6 versus 5 is obviously going to give you a different number. So just something to be aware of. And that's calculating covariance and correlation. If you have any questions, please let me know.